look at a future value annuity, and we're going to try to relate it to a geometric series formula. Okay, so we have our word problem here, and then we'll read through it quickly, and then we'll kind of choose which annuity, and by the title we've kind of given it away, but which one we're going to use. So Logan is retiring in 4 years. Okay, so that's actually going to be important information for us. He's going to take a trip and has an estimated cost of $8,000. Okay, $8,000. How much money should he invest every 6 months? Okay, that's also important. If the investment will earn 6% per annum, which means per year, compounded semi-annually. Okay, so this part here, and I guess I should use a different color for that. Let's do, yeah, okay. I want to just highlight this part. Compounded semi-annually, and the fact that it happens every 6 months. For us to use these types of annuities, so the formulas we have below, whether it's this sequence or it's this future value, you need to have the dates that you're putting money in and the compound period to actually be the same. Otherwise, we got to do a lot of extra thinking. Okay, and I'm going to go on the assumption that you're probably going to be giving questions where these are the same, so you probably won't ever have to worry about it. Okay, but just, I guess, keep that in mind because there is a difference. If these things are separate, then it's a little more thinking to the question. But, okay, we have our important information. So, the estimated cost when he goes on his trip when he retires is going to be $8,000. So, at sometime in the future, he needs $8,000. So, we have our two annuities. This A1 stands for the future value amount, and this stands for the present value. Literally by the name, we can tell because he needs that amount in the future, we're going to be replacing the future value with our 8,000. So we'll be using this one. So let's kind of relate these since you have a little bit of background with a geometric series. Okay, your sum of your series here, okay, is essentially the total amount of a future value. So the S at N and the A are the exact same values. In the formula for future value annuity, this R stands for the regular payments. So how much are they paying? And in this case, every 6 months. And that's actually what we're trying to find in this question. For geometric series, that is the first term or the start number. So that's your A and your R are the exact same thing. Okay. Now, the R in the geometric series, which is the common ratio, is actually broken up. We've expanded it a little. Okay, so whatever the common ratio is, so that's usually because a geometric series is like a type of exponential or multiplicative question, you're increasing by a percent. And what this breakup does here, okay, assuming you're earning money, is whatever the percentage rate is, which is kind of our 6%, we'll have to kind of isolate I a little more, plus the 1. And the 1 stands for the 100%. In other words, you're going to have 100% of your money plus a little bit more. Okay, because you want to be earning money. Otherwise, if you're less than 1, you're actually losing money. Okay, so that's why they've built a 1 plus I here. The N, the number of terms, is actually really similar. It's the number of compound periods in the future value. Okay, and then you have your subtract 1, which is the same in the geometric series. It's the exact same number. And then again at the bottom, your common ratio minus 1 is actually your I, and you can kind of see the relationship here. 1 plus I was R. So if you isolated R, it'd be R minus 1, so it's kind of rebuilding that. So they are actually the same formula, just kind of different letters, and we describe each of the letters differently. Okay. Okay, so now let's actually focus on how to solve it using this formula here. So we know the future value is $8,000, so that's going to replace our A value. So let's call that our A. Okay, A is 8,000. The I, if you remember from compound interest, has to be calculated. I is actually the interest rate divided by the compound periods. Okay, so I'm not sure if you recall doing that, but I is usually they'll call this the R, the interest rate divided by compound period. So the interest rate in ours is 6%, so 0.06, good. And the compound period, and because it's per annum, that's important, semi-annually is, yeah, so it's twice a year here. So this is going to happen twice. Yeah, so we're going to divide by 2. So our actual I value is 0.03. Okay, so that's what we're going to plug in for I. Okay, and then the final one we have to calculate is the N, and the N value is compound period times number of years. So he said it was going to be 4 years, but it compounds again twice a year. Okay, so really what it's asking is how many times over the life of this are we going to compound? And because it happens, yes, exactly, 2 times a year for 4 years, our N value is 8. Okay, so now that we have all that information, we rewrite our little our formula here. I get it all in. Yeah. Okay. So A is our 8,000. Okay. Which is equal to R is our actual unknown. We don't know, and that's what the question asks. How much money do we have to put in every single compounding period?
Okay.
1 plus Ri, which is 0.3. So I'm actually just going to put that all together in one shot. 1 plus that would be 1.03. Okay, and that would be like the common ratio if it was a geometric series. Our n value, so the number of terms or the number of compound periods is 8. Subtract 1. And all divided by, again, our n value, which is 0.03. Once you get to this step, oops, yeah, it's just, that was kind of in the wrong spot. There we go. It's isolating or bed mass, really, okay? So, in fact, since we're pretty decent at math here, I'm going to bring everything over without actually doing any calculating and do all the calculating at the end. Okay, so this is what I mean by that. Because this is all divided by 0.03, we would first move 0.03 over. So instead of actually calculating, I'm just going to put 0.03 in brackets times 8,000. Okay, and you could get a value for it. It's probably not the hardest thing in the world.
Divided by.
Yeah, exactly. And divided by whatever all of this is going to be. Good. So I'm just going to write it out again. 8 minus 1 instead of, because this will probably be some kind of repeating number. Okay, so that's why I just didn't want to calculate it. Yep. So to isolate R, we now just divide by that. So we have 0.03 times 8,000.
Divided by.
Yeah, exactly. And R is equal to all of that divided by whatever this value is, which is our 1.03 power of 8 minus 1. So this is what our R value is going to be. So once we have the values, when you go through this formula, not the hardest thing in the world. So you can calculate it all this way. And if you preferred calculating it one step at a time, there's no difference. But let's try this out. We have 0.03 times 8,000. Okay, and all of that's going to be divided by, I think I need two brackets, 1.03 to the power of 8 minus 1 and bracket.
Negative 1.
I get almost $900. Oops. $899 something, and we'll take a look at what you got there. $899.65. So $899.65, and there might be a little error approximately. So let's go look up what you did here.